All right, 10.5, angle relationships in circles. So a little bit of warm up, just for a little bit of review. So find the indicated measure. All right, so remember, first off, we're trying to find BC, but let's go with what we know. When we have something like this, ACB, okay, then the relationship is if this is 30, this is double, that's 60. Now AC is a diameter, so that makes this 180. Which also makes this 180. So if this is 60, we have two ways to do this. We could add 180 and 60 and subtract from 360, or easier, 180 minus 60, which would give us 120 degrees right there for that arc. Okay, the measure of angle P. Well, right here we have 77. Right here we have 135. 135 plus 77 is 212. That means RQ here is 360 minus 212. So that's 148, right? So this is 148 degrees. That means this is half of that, which makes it 74. Now, notice FEG right there and FHG both have this same arc right here. Whoops. A little technical difficulty. Hold on, please. There we go. Also, going the other direction, here and here, same arc, EH. Okay, but we have this angle right here, so 42 times 2 makes this 84. If we were doing it, this would be 100, okay, because of the 50 right there. All right, another theorem, tangent and intersected chord theorem. If a tangent, remember tangent is right here, just touches the circle once on the outside, and a chord intersect at one point, which is point A, then the measure of each angle formed is 1/2 of the measure of its intercepted arc. All right, so let's look at that. The measure of angle 1 is half of AB. Okay, so this right here is half of that arc. So angle 1. Angle 2 is half of this arc, BCA, the major arc. Let's see how it works in action with real numbers. All right, so we have 130 for this arc right here. That means angle 1, since it is formed by this tangent and this chord, angle 1 right here is half of that, so 65 degrees. Now, this time, notice we have the angle measure of 125, which means this arc is 250. Intersecting lines and circles. So if two non-parallel lines intersect a circle, there are three places where they can intersect. They can intersect on the circle, inside the circle or outside the circle. Just a concept. Now, with that concept, we have various situations. If the angles are inside the circle, theorem. If two chords intersect inside a circle, then the measure of each angle is 1/2 the sum of the measures of the arcs. Okay? So since AC and DB cross inside the circle, if we add this arc and this arc and divide by 2, okay, that will be the measure of angle 1. Okay? For angle 2, we'd be going this way. AD and BC will give us angle 2. Notice how 2, okay, is facing that way and 2 is facing that way. So it's those two arcs. And 1 is facing that way and that way, vertical angles. So it's those two arcs. Okay, it's the intercepted arcs. Then, if it's outside, if a tangent and a secant, remember a tangent only touches once, a secant is basically a chord that continues through the circle. If a tangent is secant, like that, or two tangents, or two secants intersect outside the circle, the measure of the angle formed is 1/2 the difference of the two arcs. So this time, we're going to take this one minus this one and divide by 2. This one minus this one, divide by 2. This one minus this one, and divide by 2. So inside we add, outside we subtract. You will get formulas for this. You will not have to memorize these. You just have to know how to apply them. All right, so A, they're intersecting inside the circle. Notice X is here and here because of vertical angles. They're facing this direction. Okay? So, since they're facing that direction, we're going to add these two arcs. 156 plus 130 divided by 2. Okay? Which gives us 143 for the measure. Okay? On number 2, B, it's outside the arc. So we're going to take this minus this. 178 minus 76 divided by 2, which gives us 51 degrees. So inside we add, outside we subtract, and then divide by 2. Circumscribed angle. A circumscribed angle is an angle whose sides are tangent to the circle. Okay, so we have two tangents, we have the circumscribed angle. Now, what's the theorem? The measure of a circumscribed angle is equal to 180 degrees minus the measure of the central angle that intercepts the same arc. So let's see it in practice. Okay, so find the value of X. In this case, since we have these two tangents, the intercepted arc is 135. So we simply take 180 minus 135 and we get 45. So this is 45 right there. They're supplementary. Okay, now this one's a little bit tricky. B. Here we have to combine some ideas. So previously we learned that, let's say this right here was 10, then this would be 20, right? It's double. So since we only know it as X, that means this is 2X. Well, this angle here is equal to 180 minus the central angle. Well, we don't know what the central angle is right now. It's only 2x. So we do a little bit of algebra. 30 is equal to 180 minus 2x. So we subtract 180 from both sides. That gives me negative 150 equals negative 2x. So when I divide by negative 2, x ends up being 75. So we had to combine two ideas there to solve that problem. Then last but not least, the northern lights are bright flashes of colored light between 50 and 200 miles above Earth. A flash occurs 150 miles above Earth at point C. What is the measure of BD, which is right here, arc BD, the portion of the Earth from which the flash is visible? Earth's radius is approximately 4,000 miles. So that's here and here. Okay? And then the distance from A to C is 4,150. So if we look at this, what we have is two triangles. Okay, this is the right angle here, up here at D and at B. We know that this is 4,000, and we know this is 4,150. So this is my A, that's my C, that's my B. Now, unfortunately, we're not just trying to find the distance at B. That would be easy. A squared plus B squared equals C squared. We're trying to find the central angle right here to help us get this arc right here. So we're looking for this, which is only going to be half of it, but we can simply double. Okay? So from this angle, what do we have? We have the we have the adjacent side right here, and we have the hypotenuse. So that means we're doing cosine of some angle, we can use x or theta, doesn't matter, equals adjacent over hypotenuse. So we're going to hit second cosine on our calculator. Because anytime we're trying to find an angle, we hit second cosine. 4,000 divided by 4,150, the hypotenuse. And if we round to the nearest tenth, that's 15.5. But that's only half of it, right? So we need to double that and get 31 degrees. So, being a central angle, if this is 31 right here, or do a different color so you see, then this is 31 right there. And that's it.